Hello everyone. Today we have Michael Carpenter as our guest speaker. Here's Mike on the top right side of the screen. So he's going to tell us about his path, his career path, his professional experiences. So I will let him tell you about his background. And then at the very end I have asked him to tell us some good ideas, the good recommendations for you all for the future in school as well as your career. Thank you, Mike, for being with us today. I really appreciate your time. So I have your first slide up and running. Says guest speaker Mike Carpenter. So you just tell me when to advance. And again, thank you for being with us.
Absolutely. All right. Just to give you a little bit of background, after the first slide there, currently I'm a GIS and CAD draftsman for an environmental engineering and consulting company in St. Augustine, Florida. I was born in St. Louis, Missouri, lived there until I was about 20 years old. From there, I moved on to Winter Park, Colorado, from St. Louis after basically high school, and was a ski bum there for a while. I was kind of figuring things out. From there, I moved to Denver, and I graduated from the University of Colorado, Denver in May of 2011. With a degree in geography. Then in July of 2011, I moved to St. Augustine, Florida. The next slide. And just to give you an idea of my education and professional path, including the University of Colorado, like I said, I have a bachelor's degree in geography. I took the concentration for the chemical environmental science program, as well as a member of the UC Denver Geography and Environmental Science student group for a little bit. Some of the courses that I took that are probably pretty similar to what everyone is taking right now, as far as GIS, will be the Introduction to Cartography, Computer Mapping, Remote Sensing 1, GIS, and Environmental Modeling with GIS, which I took with Raphael. And I knew I was moving to Florida, so I took my independent study here's my son, he just got up. All right, and then I made an independent, let me start that again. All right, and then after my environmental modeling with GIS in my last semester at UCD, I chose an independent study that entailed mapping hurricane densities in the state of Florida. And with that, I took information from NOAA and I used the kriging method to determine different densities of what areas are more prone to being hit, more or less. And we kind of chose to move to the area that is the least hit, which is Northeast Florida in St. Augustine. Also, during my semester abroad, I went with Dr. Casey Allen and Fred Chambers to Grenada, and there, related to GIS, a couple of us used Trimble GPS units to record water data on the Atlantic side and the Caribbean side, and I think he is using that data now, as well as some water data throughout some of the rivers and streams on the island there. Moving to the next slide. This kind of details where I live now. Northeast Florida, St. Augustine, Florida. It is the oldest city in the United States. Founded in 1565. It's where Ponce de Leon came to find the Fountain of Youth. So there's a lot of very rich history here. And I know there's a lot of archaeology companies here that also use GIS in that regards as well. So pretty neat. Lots of different beaches, world-class fishing, architecture as well, and also in the neighborhood I actually live in, which is kind of the downtown area. It was one of the pivotal sites with MLK and the civil rights movements, so pretty neat. And on to the next slide. After first moving here, I didn't have any contacts, didn't know anyone, so I decided to volunteer at a place called the Guantanamo-Matanzas National Estuarine Research Reserve. That's an enormous name, and that is a program that's set up with NOAA and different EPA Environmental Protection Agency across 26 different coastal areas throughout the United States. So this is one that's closest to me. And with volunteering, I became involved as volunteer park ranger, and also I would ground truthing with GPS for their GIS analysts. And I was also worked for doing invasive species control and prescribed burn duties. And the picture I have here, this is clearing out a fire break line, getting ready for a prescribed burn. So that's a good way to meet people in town here, and it really solidified that I knew that I had gone to school for the right thing, and it was something that I definitely want to be a part of. So moving on to the next slide. I also decided before taking this job, actually around the same time, the job that I took as this GIS AutoCAD draftsman, I didn't have any experience in AutoCAD, which is civil engineering uses a lot, and also for a lot of the projects that we work on, we get a lot of data in AutoCAD form from surveyors and surveying companies. So I decided to enroll in a certificate program through the University of Florida that focuses on geomatics, and that allows me to become more efficient in AutoCAD and as well as GIS. There's a couple GIS classes that I'll be taking as well later on, so it'll be good to kind of come full circle with that. And a lot of these classes deal with field methods for collecting data, for doing TINs and different stuff that goes on for contour mapping. So a lot of raster data, well, not raster data, but line and point data that we use in GIS a lot. Another benefit, I hope at some point, our company right now subcontracts out all our surveying, so I see it, and my company saw it as a benefit that I might be able to bring the surveying in with just a little bit of equipment to something we do in-house here. So the classes I'm taking for the certificate are geomatics, survey computations, cadastral principles, surveying and mapping practice, route geometrics and design, and currently I'm in visualization of spatial information, which is pretty much an introductory course to AutoCAD. And I'm finding there's advantages for AutoCAD and GIS, and it's nice. Software on both sides is able to cross over to meet the needs of companies. And also I'll be taking some GIS classes. And moving on. My current career, as I mentioned before, I'm a GIS and CAD draftsman. I utilize ArcMap 9.3, which is, at the time when I was at University of Colorado, is what we used. And in my final semester, the university switched over to 10, which I'm guessing is what is used there now still. In addition, I used AutoCAD 2009, as well as AutoCAD Civil 3D 2009. So kind of day-to-day responsibilities for me, what we're doing is working with a mining company that is putting together a plan for remediation for a giant mining site. So right now we're in the stage of a lot of monitoring. And with this, we'll go out in the field. Something new for me, even in the past couple of days, is I'm going to be taking on more field work as well. So I have more HAZWOP or OSHA 40-hour class I'm going to take. So I'll become more involved with getting out in the field and collecting data as well. So with the data that I get right now, I do soil and groundwater mapping. I make a ton of maps a day, anywhere between 5 and 15 maps a day of groundwater contours using raster images, and then basically interpolating from points that we have from various monitoring wells and piezometers, which record different, or when we test them, record different aspects, whether it's water pressure, ranges, I should say. A lot of what some of the things I do is facilities process diagramming, and that kind of involves with taking AutoCAD data and along with this groundwater mapping as well and putting together. I do tons of my work just revolves around GIS data management. The data I'm using now just for this particular project is about 4 gigs of just GIS files and different data. And when I took over for another guy who'd been there 2 years, and so there's definitely a way that how I was able to get right in and kind of continue. All right. Also, really a major part of my job is GIS data management. With this, I took over for another person who'd been there in my position for 2 years, and the projects don't stop rolling in, the data doesn't stop rolling in, so real quickly I had to figure out how you organize all this data, which for this particular project I believe is around about 4 gigs of just maps, layers. We put together a database for this mining facility that has the groundwater contours taken at different months, all this data. So it needs to be organized very well. And I will get into that a little bit. I'll kind of show you some pictures of different things I do with that. Also spatial analysis, data analysis, and then the list goes on towards the right that kind of goes on. I'm trying to think, there's a lot of this stuff is stuff I learned with Raphael in GIS classes. Data acquisition, going out and finding labens or different sites that provide aerial photography that we use. Luckily, right before I got there, the man who had previously had my position, he went ahead and he ordered pretty much raster images for the entire state of Florida, every county, and our catalog for just aerial photos, to give you an idea of the size of these files, is about 480 gigs, all of raster data. So it's, as I learned in modeling, it takes up an extremely large amount of space, and that's, to see things, it was one thing to hear about data in school when I'm dealing with one raster image at a time, but to see it in a professional setting, how much that quickly adds up is pretty overwhelming, pretty amazing. Digitizing, data conversion with AutoCAD. Sometimes I have to bring in different files and bring that into GIS. And really, with my job, I'm the only one in my department. No one else at my company knows anything about GIS or AutoCAD, so I have to figure out everything by myself. But that also gives me the choice to how I want to do different projects. In some cases, I'll use AutoCAD for a part of this facility that I have survey notes from, or survey drawings, where I have precise measurements. A lot of times for ground watering, I'll use our GPS coordinates that when we go out in the field we collect, and I'll do digitizing with not digitizing, I will create points from that, and then from there do my groundwater contours. Do a lot of editing using the tables. The presentation mapping, every report we do has at least, it's going to have at least 10 or 15 different maps, and that's kind of a general kind of average. It depends on project to project, but some of these projects or these reports, when they finally go out, our company just submitted to the state for a project with this mining company that we work on, was a binder about this big, and it had about 20 different maps in there. And also GPS data management as well for all these points that brought in. So that gives you a pretty good idea of what I do. And moving on to the next slide. This kind of goes with how I learned to approach GIS for each unique situation. That's the approach Raphael taught me. I still have my notebook from my environmental modeling class by me in my office, and I constantly go back when something's a little overwhelming at first to just kind of simple things, take a breath, and I follow these 6 steps, which I'm sure he still teaches in class. So definitely a major part of my day-to-day operations on newer things. All right, moving next. This kind of give you an idea on the current project that I was kind of hinting at before. So as I mentioned, we've been hired by a mining company to do an investigation on the groundwater, different areas of this before they go off to sell this area, or if things are too bad, they might just end up buying the area themselves. So to give you an idea about the size of this area, what they've done is over time, this is a mining facility that's gone on for 60 years, and they have their own property there, but they have also leased land from families or different companies throughout this area that stretches about 8 miles wide to 13 and a half miles in length, giving it, plus or minus about 108 square miles. So we are right now in phase 2 of an environmental site assessment. With phase 2, this is where we're doing all of our monitoring. Phase 1 basically says it's an investigation of what's been done, what needs to be done. Phase 2 now is constant monitoring of what's going on. And then phase 3, when we eventually get to that point, is going to be remediation and, taking appropriate actions to clean up that land. Aside from us, there's us working in this area. There's also a wetland kind of company that specializes in rebuilding wetlands from mining facilities. And with that, the idea is, as it acquires groundwater, these wetlands will naturally, as they grow, clean up the land too. Because as you can imagine, with mining, there's a lot of nasty stuff that goes on. All right, moving on. All right, let's see. This kind of goes back to daily techniques that I do. And I've talked pretty much about digitizing groundwater contours with the optimal locations. A lot of times when the scientists go out, I will give them a field map, an aerial image, and from there they'll go ahead and they'll mark up on that as they're out there. It's just something real simple for them, real easy for them to do, because down here it gets very hot, so they're sweating, it's dirty, they're digging, they're boring out ground samples, so this helps them just to jot down notes in a kind of geographic reference. I create shape files all the time for different monitoring well points. I will take these field maps at times that they've drawn on, and I will geo-reference them back into GIS. And with that, I will, if they've created the groundwater contours, I will follow the path they have, or a lot of times I'll calculate the contours on my own. Also, everything that we send in, again, out of their toolbar, I use that a lot to make these contours. Back to how we manage our data, with every map I make, I also make a PDF that will go in these final reports. So because as you know, you just can't give somebody an MXD because it's not going to have your data behind it. So that's why we create PDFs with everything and extremely organized in the naming of those. Moving on again, as I mentioned, I have a choice of using GIS or AutoCAD. The only person in the office that utilizes this or really has an understanding, so it's at times a lot of pressure on me. And I think a definitely in my environmental modeling class, I learned more than anything. In most cases, even at my work, we don't have all the extensions that you may have there at the school. So you have a lot of very strong tools to use there. For instance, spatial analyst. That's why I'm drawing in these groundwater contours, because we do not have the spatial analyst extension, which, in some cases I could use that to come up with these contours. And with that also, brings to light the importance and how powerful open source software is too. With everything coming out now, these things are communities are writing these analyst programs that are available for everyone to use, and that's definitely a very amazing thing to have. Opens up a lot of opportunity for everyone. And also, just using AutoCAD blueprints and surveys, that was a total new language for me. So just understanding how those work, it gave me, again, in my computer mapping class, I had an idea of surveys and meets and bounds, and so this is something that I use every day. And with the classes I'm taking now, it goes along very well. In the background there, this is at my office. This is a map. This is a reference map of the area we're working in, and this thing is about 5 feet tall. So I'm constantly printing up maps from our plotter, and it's pretty amazing creating maps that big. It's about 5 feet by probably about 3.5 feet wide. All right, moving on. Let's see here. All right, now let's get back to my data management, which is probably, again, one of the most important things about my job. For this one project, as I mentioned, we have about 5 gigs of GIS and AutoCAD data. And I took over, things don't stop as I took over, so that, so they could train me. Data just kept coming in. So within working with this company, this one project that encompasses the mining company, within that we have 44 different projects, so to speak, ongoing. Different monitoring, either through groundwater, through soil, and different areas to that giant area that I was talking about. And next, this kind of illustrates the need for practicing excellent data management. And I've attached some pictures. I've sent them with Raphael. I have a tree diagram of just how much, to try to give you an idea of how much data is in these projects. It's kind of tough to get an idea once you look at it, until you look at it, but you'll see that all these, within these 2-3400s where it's highlighted in the blue rectangle, these are some of those projects within that for that mining company. Then moving on to give you an idea how I keep everything organized and how I know where to go. If you'll notice I've attached a figure 1 and figure 2.